Hello, math champions. In mathematics, you have learned many things like measuring temperature, measuring a volume or area, right? Or even, other things like speed. All of these things you'd have learned to measure these things, right? Now all of these things, how do you measure what is the value? Like if the value is big, the number, we give a bigger number to represent it. And whenever the it's a bigger number, it's bigger in value, the more, right? If, like, say for example, if it's 28 degrees Celsius, right, and it's a 36 degrees Celsius, and we know that this is greater than this, right? So we are measuring some things by how big it is, how less it is, how more it is, right? This how big, how less, how more, this concept of big, less, more, this is called as magnitude. So there are many quantities based on this magnitude we measure, right? If say for example a speed, right? If it's a 38 kilometer per hour or something else is 100 kilometer per hour, we know that 100 kilometer per hour is greater, right? So we compare things based on magnitude, and all such things which have this kind of measurement is called scalars. So all of this time you have been learning about scalars. Now, it doesn't matter whether this car is going in this direction or this direction. Okay, let's say this car, let's say car A is moving in this direction, like say from one city to another city. It is moving in this direction at 38 kilometer per hour. And this another car, okay, there's another car B, which is traveling at 100 kilometers per hour, right? 100 kilometers per hour. And now it doesn't matter to me where from which city to which city it is going. And I just know that the second car, car B, is faster. That's all. That's all matters. It doesn't matter which direction it's going, right? So these are called scalar quantities, right? Because we are talking about only about the magnitude, how big, how less, how more. These are the things. But sometimes it becomes relevant to talk about the direction as well. For example, when we talk about things like acceleration, or we talk about things like force, right? I, say for example, if I am putting force on a certain box, okay, if I'm putting force on this direction, okay, let's say force is measured in newtons, right? That's the quantity, the unit of the quantity. So if I'm putting 6 newtons force this side, and somebody else is putting 9 newtons force the other side, now you tell me which side the this box is going to move. Yes, it is going to move this side because here the value is bigger. And just because the value is bigger doesn't matter. It's also because it's in this direction. That is why this box is going to move in this direction. So when I'm applying force, when I'm talking about acceleration, when I'm talking about some say velocity, these times it is not only the measurement of how big it is, how more it is. These are not the only things that is matters. It also matters the direction also matters. So these are called vector quantities. Vector quantities are quantities where magnitude as well as the direction is going to be there or is going to be relevant. Magnitude and direction are going to be relevant in this. Such quantities are called vector quantities. So mathematics helps us to measure different phenomena, different things. It helps us in different science, right? Physics, chemistry, all of these things. So when we talk about all of those things, we will use scalar quantities, sure, but we also are using vector quantities. So because we are going to use vector quantities, measure them, manipulate them, change them, add them, subtract them, we are going to do all of those things. It becomes necessary for us to learn vectors in mathematics so that we can deal with items, deal with situations where we are talking about acceleration, force, and velocity and all. We will know how to add them, subtract them, all of those things, right? That is why we learn vectors. So as we progress, we keep on improving or keep on growing in mathematics. We learned about absolute quantities, right? Absolute quantities is scalar quantities, which has the magnitude. And you also would have learned in your previous classes when we say what is the absolute quantity of, say for example, what is the absolute quantity of minus 6, or we also say magnitude. What is the magnitude of minus 6? And we know what is the magnitude of minus 6 means. It is going to be 6. That means the value is 6, right? The sign is going to tell me in what direction it is. There's also one more way when we talk about integers also, right? It tells about which direction it is. However, so vectors have both magnitude and direction. Now, how do we represent vectors? Okay, we can represent vectors in the format like, for example, we can say A, B, and this direction, right? Direction is represented by the arrow there. Or we can say it is a B, A, and this direction. What is the meaning of this is I have A point here, it's a B point here, and AB, if I just write AB, that means it's the length of this thing. Okay, it's the length of this line. But because there is an arrow, I know it is from this to this. Same if I have to represent BA. Okay, now if I'm having the same A here and same B here, but because it is a BA, I will say the direction is this side, right? But both of this AB and BA, whatever they are, the magnitude is same, right? So now, for example, if I had represented this on a coordinate axis, let's say there's a x-axis, there's a y-axis, right? If I had represented this like this, I will know that the distance from here to here would be actually be the x part, x coordinate, right? And the part from here to here, right, that will be y. So for this AB vector, I can also represent it as like a column vector. Column vector means I represent by x and a y here, right? Let's say, for example, this was a 4 and this was a 1, okay? And this was a 2 and this was a 3, let's say, right? So now what do I know? How much is x? It is 3, right? The distance from 1 to 4, it is 3. And y will be distance from 2 to 3, isn't it? So it will be 1. So I can represent AB vector like this. XY means it can be represented by a column vector like 3, 1, written one below the other. And if I say what is the magnitude? What is the magnitude of this AB? It is simple. What is magnitude? What did I say here? Its magnitude is nothing but the length of this, right? How much is the length from here to here? If you have learned a coordinate geometry from my videos or anywhere else, you would have understood that when I know these values, like I know the length of this x coordinate is 3, x part is 3, and the y part is 3, y part is 1. Using the Pythagoras theorem, I can find out what is the length of this black color line, that is AB, right? How do I find out? By using Pythagoras theorem, right? I am going to draw it again. This was our A, this was our B, and we found out that distance from here to here is 3 and here to here is 1. So how do I use the Pythagoras theorem? From this, I know that AB will be equal to the root of 3 square plus 1 square, right? So, if I'm having a vector AB bar like this, then the magnitude can be given by root of that x square plus y square, where AB is given by x, y here, right? X, y here. Now, if it is only magnitude, then how am I, magnitude is going to give me how long that line is, how long that vector is. Okay, that's what it's going to give. But vectors don't have only the length, right? Length means it will be a scalar quantity. Vector has direction also. So how do we define the direction? for defining the direction, we use angle, right? So if this was theta, right? If this was theta, then this angle is going to tell me the direction of this, right? And it is AB, right? So I can give the direction by saying what is the tan theta? Tan theta is 1 over 3. So using this, I can give theta is tan inverse of 1 over 3, right? This will give me that, okay, this is the direction. This is the slant of that line. So it's going to give me that thing. Now you might say, tan theta is it always like this? No. See, in the same vector, I mean, if I take a different vector, let's say PQ, right? Let's say this is P and this is Q, and the direction is this way. Now, how would I find the tan theta? Is I write this like X and Y lines, like perpendicular lines, and then this theta, right? Now, let's say this length is X. We know that this length y, it is y, of course, but then it is in a negative direction, right? So it will be a minus y, isn't it? So PQ vector, how I would be representing as a column vector is x minus y. Here, if you see, the magnitude will not change. Because when we write a magnitude of PQ, we can write it like this, magnitude like this. It will be root of x square plus minus y square only, which is nothing but root of x square plus y square only. Doesn't change. But then the tan theta will be minus y by x. So this will make it a little different from this positive angle here, right? So this I'm showing to you to differentiate that, okay, the angle is going to help me identify the direction, whether it is going upward, AB is going upward and PQ is going downward. So we're talking about this direction also using this angle. So I hope you understood what is vector. Okay, a quick recap of this video. We understood that there are several quantities called scalar where magnitude only is of importance, but vectors are quantities where magnitude as well as direction is important. Because, for example, again, if it's a plus 6, I know it is on the right side of the number line. If it's a minus 6, I know it's on the left side of the number line, right? So the direction also matters. Such quantities are called vectors. And when we say vectors, we represent it by AB, and we also represent it using a column vector X, Y. What is the meaning of X, Y? How much on the X axis it is, how much on the Y axis it is. So that is what we're talking about. And then we also found out that using this column vector representation, how we can find out the magnitude of it. We use the Pythagoras theorem to find out the magnitude of it. Take the x and y coordinates, use that inside the Pythagoras template, root of x square plus y square. I will get the magnitude of that vector. And because vectors also have direction, that direction can be found out by using the tan theta concept, the trigonometry concept. We can use that to find out whether a vector is going upward or downward or left side or right side. We will know these things based on the theta that we find out, and theta will be nothing but tan theta will be y over x. In that way, we can find out the magnitude as well as the direction of a vector. I hope you understood what is vectors, how do we represent, how do we denote, what is the notation of vector, and how do you find the basic magnitude and direction of a vector. We'll talk about more things about vector in the next video. I'll see you in the next video. Until then, keep practicing to identify vectors and keep practicing to denote vectors and to find the magnitude and direction of vectors. Keep practicing. I'll see you in the next video. Until then, see you. Bye-bye.